Welcome to 6 Docker Projects for Absolute Beginners tutorial. I'm Otabak, a junior DevOps engineer, and I will be your instructor in this video. You are going to have 6 different projects that will help you to explore Docker with hands-on demos. Before we start, let me briefly show you the projects that we are going to go through in this video. So we are going to start with creating a secure connection between containers, and this will be our first project. Here specifically, we are going to learn how to set up SSH connection between 2 Ubuntu containers in Docker. Then we are going to move on to web servers, and here we are going to learn how to Dockerize an Apache web server, and we will also learn how to Dockerize an Nginx web server. And finally, we are going to move on to hosting applications, and here you will be learn how to Dockerize a simple Python Flask web application. And you will also learn Dockerizing a simple Node.js application. And finally, we are going to finish our last project with Dockerizing a WordPress site. So that will be 6 projects. But as you can see here, there are more than 6 projects, but I have not finished them yet. And this will be the first half. That's the first part of this tutorial. So if you like the video, and based on your likes and the views, I'm going to post the second half of the video. And there we are going to learn how to Dockerize a Django application, how to Dockerize a React-based front-end application, Dockerizing a PostgreSQL database, Dockerizing a MySQL database, and many more. But now let's focus on the first half. So also I have to mention that here, as you can see, I'm not including any installation part. So I would highly recommend you to install the Docker on your Mac or Windows or Linux. And also I would highly recommend you, if you're using Windows, to install the WSL, Windows subsystem for Linux. And because I have used that during this project demos. But if you are using a Mac OS or Linux, you can use the terminal. But anywhere you have to install the Docker on your machine. So you can go to the official documentation or watch other YouTube tutorials on that, because I didn't include that on this video. So let's get started. Hello and welcome to the first project on setting up SSH connection between 2 Ubuntu containers in Docker. In this video, I'm going to briefly give an overview of the Project 1 so that you can get some idea about it. This project involves setting up and establishing a secure shell SSH connection between 2 Ubuntu containers in Docker. First, we are going to run container 1, which is Ubuntu container, after pulling it from Docker Hub. Then we will do SSH configuration. Specifically, we are going to install OpenSSH server package on the first container, container 1, because it allows the container to act as an SSH server and accept incoming SSH connections. This package includes the necessary components for running an SSH server. Next, we will run a second container, container 2, and do the same SSH configurations. But this time we will install SSH client package because it allows the container to act as an SSH client and initiate outgoing SSH connections. Also, the package includes the necessary components for connecting to an SSH server. As soon as we are done with containers, we need to set a new password for the root user inside the first container. Finally, the end result is 2 Ubuntu containers that can communicate with each other securely over SSH. Now, what are the key takeaways from this project? Or in other words, why we need to learn how to set up SSH connection between 2 Ubuntu containers in Docker? Well, first and foremost is improved security. By setting up an SSH connection between the 2 containers, you have established a secure and encrypted connection that ensures confidentiality, integrity, and authenticity of the data transmitted between them. This helps to protect your application and data from unauthorized access and data breaches. Second, easy of management. Docker makes it easy to manage and deploy containers, which helps to reduce the complexity and the time required for managing your application infrastructure. By using containers, you can easily move your application from one environment to another, making it easier to test, deploy, and scale your application. Third is better collaboration. With this project, you can enable multiple team members to work on the same application simultaneously, as each team member can have their own container that can communicate with other containers over SSH. This can help to improve collaboration and productivity, as team members can work independently and share their work with each other in a secure and efficient manner. Fourth is scalability. Containers are lightweight and can be easily scaled up or down to meet the changing application demands. By using Docker, you can quickly spin up new containers as needed to handle increased traffic and then shut them down when traffic decreases. This helps to optimize resource utilization and reduce costs. Last but not the least is portability. Docker containers are highly portable, which means that you can easily move them between different environments and cloud providers without having to worry about dependencies or configuration issues. This can help to simplify your application deployment and management processes and reduce the risk of downtime due to environment-specific issues. I would highly recommend you to try this Project 1 as an assignment before going through it with me in the next video. Good luck, and I will see you in the next lecture. Hey everyone, so let's get started to create our first project. So first thing first, we need to run Docker image. So in order to run a Docker image, first we need to pull that image from the Docker Hub. So let me go to my browser and see the Docker hub.docker.com. And if you go to the Explore page, you will see the list of images like Ubuntu and Nginx. You can see Python. You can also search on top. Here you can say, for example, since we are going to pull the Ubuntu image, I'm going to search Ubuntu. And as you can see here, we have a Ubuntu image. If you click on that, you will see the list of information like supported tags, quick reference, like what is Ubuntu and what's in this image, like this. So on the right top section, you can see the command docker pull Ubuntu. So we need this command. So let's copy that. And then let's go to WSL, and I'm going to press Ctrl Shift and V, and I'm going to click on enter, and this will download, this will pull the latest Ubuntu image from Docker Hub. As you can see, it is really fast because I have already downloaded it before this video. So in your case, it might take a few seconds, so you need to wait a bit. So after you have pulled the Ubuntu image, you can run Docker images, and you can see there is a Ubuntu repository with a tag, image ID, creation date, and size. So as soon as we're done with pulling the Ubuntu image, we need to create a new directory. Let's say new folder. I mean Project1 mkdir. Let's name it as a Project1. And if I do ls, you can see we have a Project1 folder. Let's go to this directory, Project1. And if I do pwd, you can see we are inside home, Autobag, Project1. So Autobag is just my name. So inside the directory, we can start running our first container. So now we will create our first Docker container. In order to do that, I'm going to run docker run it, and then the name would be container1. And the name of the image is Ubuntu. All right. So this will create the new Ubuntu container with the name container1. The IT option will start the container in interactive mode. So you can see we are inside the interactive mode, inside the container. So now we need to install SSH in the first container. So we need to run the following command inside the container: apt get update. And of course, it will take a few seconds. If you want, you can fast forward the time. And now we need to install OpenSSH server. For that, I'm going to run apt get install OpenSSH and then server -server. Click on enter, and this will install this OpenSSH server. And you need to wait a few seconds or minutes. So as you can see, it's done. I have just fast forwarded the time since it took about 2 or 3 minutes. So now we need to configure SSH in the first container. So for that, we need to edit the SSH configuration file using the following command: apt get install nano first. So first we need to install the nano. And after that, we need to run the following command: nano, and then and then the slash etc and ssh, and inside the ssh we have sshd and then sshd and config. And if I do enter, you can see we have a list of information. So you need to basically uncomment the following line. Go to authentication part here. You can see the authentication here, right? Let me show you. This is authentication section. So you need to uncomment these. Let me show you here. Uncomment this. Let's do edit. Let's go to below. Yeah, I'm going to go to below. And here I'm going to basically uncomment this permit root logging. And I'm going to delete this prohibit password and change it to yes. So once you are done, you can press Ctrl S and Ctrl X, and this will save it. If I do again nano ets etc ssh sshd config, you can see we have uncomment and change it to permit root logging to yes. Here it is. So let's go back, and now we need to restart the SSH server in the first container. But before doing that, let's change the status by running the service. Let's check the status first. Status all, and you can see we have SSH, but it's not started. So in order to start this SSH, you need to run service SSH start. And you can see it's now starting open BSD secure shell server SSHD. So if I do again service status all, you will see that it's now enabled, which means it started. Okay. So now we need to go out. We need to exit. And let me do clear here. So now we need to create a second container. For that, I'm going to run docker run, and then the IT, which is interactive mode, and the name would be container 2, and that will be Ubuntu image. Let's click on enter, and you can see we are inside the second container. We need to do the same steps, like we need to install the SSH in this container. For that, I'm going to run apt get update. Now this time I'm going to install OpenSSH client instead of OpenSSH server. As you remember, inside the first container we installed OpenSSH server, but this time we are going to install OpenSSH client. So I'm going to basically run apt get install OpenSSH and then the client. And this will basically install the OpenSSH client, which is required to connect to the first container. I'm going to click on enter, and this will take a few minutes or like seconds. So let's wait, and I'm going to click on yes. So as you can see, it's now down. So far we have created Docker container 1 and Docker container 2. And inside these both containers, we have configured SSH. And then in the first container, we installed OpenSSH server. In the second container, we have just installed the OpenSSH client. So now we need to check the password for the root user on the first container. So for that, I'm going to exit, and you can do so by running the following command inside the first container. So in order to go to the first container, simply you can run docker exec -it interactive mode and container1 and bash. And it's saying that it's saying that error response from daemon. That means that we need to start the Docker container 1. So you can do it by running docker start container 1, right? So once we start the container 1, we can run the command again, docker exec it container 1 bash. And now you can see we are inside the container 1. So now we need to check the password. So let's run cat etc and then shadow and then pipe, and we need to run grep root. And you can see this is the password. So we need to so this will show you the hashed password for the root user. However, it is generally not recommended to rely on password alone for secure authentication. So in order to set a new password for the root user, we can do so by running the following command as a root user inside the first container. So let's run let's clear first, you can understand it clearly. Pass wd and then root. And you can see it's now asking me the new password. Let's give it a really simple password. Let's say 123 and then 123. And you can see now password updated successfully. So now, in order to connect to the first container from the second container using SSH, we need to check the IP address of the container 1. So we need to exit first from here. Okay, we need to exit from the container, and then now we need to run docker inspect container 1 and then pipe character and then grep IP address, right? So pipe grep IP address. If I click on enter, you can see it's now showing me the container 1 IP address 172.17.0.2. So we will need this IP address. Now let's go to the container 2 by running this command on docker exec it and then container 2 and then bash. And so as you can see, it's giving us same message. So we need to start the container 2 as well. Docker start container 2. And let's go again. Now we are inside the container 2. So now we need to connect to the first container using SSH. So we need to run the following command inside the second container. So we are inside the second container. We need to run SSH root and then add IP address. So IP address is 172.17.0.2, but you can also here copy Ctrl+C and Ctrl+Shift+V. So I'm going to click on enter. And you can see it's saying the connect to the host port connection refused. So that means we need to come back. Let's go exit here and then let's go to container 1. Let's start the container 1 and let's go to the container 1. Docker exec container 1. And let's check the SSH that whether it's running or not. For that, I'm going to run service status all. And you can see SSH is not starting. So we need to start it, all right? So I have already showed you. So you can do it by running service ssh start, and you can see it's now starting. Yes, it's now starting ssh. Now we can come back, exit, and let's go to the container 2 and run the previous command ssh root and the IP address. Now it's asking me, are you sure you want to continue connecting? Yes, I'm sure. So you can see it's saying that we need to enter the password that we have already set it, right? 123. And if I enter, you can see welcome to Ubuntu 22, and you can see the list of information. So we have successfully done this project. So in this project, we set up an SSH connection between two Ubuntu containers in Docker. We configured SSH on the first container and then connected it from the second container using the SSH command. By completing this project, we gained experience working with Docker containers, configuring SSH, and connecting to remote servers. Thank you very much and see you in the next video. Hello and welcome to the Project 2. In this project, we are going to Dockerize an Apache web server. As you can see, this diagram represents the architecture of a Dockerized Apache web server. At the top of the diagram, we have a web browser, which is used by the user to interact with a web server. When the user sends HTTP request to the web server, it is received by the Docker container running the Apache web server. The Docker container is running on the Docker host, which is a machine that runs the Docker engine. The Docker engine communicates with Docker API, which is used to manage containers and images. The Docker engine manages the container lifecycle, including creation, start, stop, and deletion of containers. The Docker container to the Apache web server is responsible for handling incoming HTTP requests and returning the appropriate responses. The Apache web server listens on specific port for incoming requests, processes the request, and returns to the response to the web server. Container networking is used to allow the Apache web server running in the Docker container to communicate with a web browser running on the host machine. The Docker engine manages the container networking, allowing the web server to receive incoming requests and send outgoing responses. In summary, the Dockerized Apache web server project uses Docker containers to isolate the Apache web server and its dependencies from the host machine. This provides a more consistent and reliable development and deployment environment, while also making it easier to manage and scale the web server. So, what are the key takeaways from this project? So, what are we going to learn after completing this project too? Well, first thing is isolation. Docker containers provide an isolated environment for running an Apache web server, ensuring that it's not impacted by any changes to the host system or other applications running on the same machine. Secondly, consistency. By packaging the Apache web server and its dependencies into Docker container, developers can ensure that the application runs consistently across the different environments, such as development, staging, and production. Thirdly, reproducibility. The Docker images are portable and can be easily shared with others, making it easy for developers to reproduce each other's work. Fourth is scalability. Docker containers can be easily scaled horizontally to handle increased traffic by deploying multiple instances for the same container. Fifth one is security. Docker containers are more secure than traditional servers because they provide an isolated environment for running the Apache web server, making it harder for the attackers to compromise the host machine or other applications running on it. Last one is flexibility. Docker provides a flexible platform for building, deploying, and managing applications, allowing developers to choose the best tools and technologies for their needs. I'm going to use Visual Studio Code for this project since VS Code has a Docker extension that makes it even easier to manage Docker containers and images. So like I said in the previous video, try it as an assignment before going through it with me in the next video. So good luck and I will see you in the next lecture. Alright, let's get started doing project 2 on Dockerizing an Apache web server. Like I said in the previous video, we are going to use Visual Studio Code for this project too. And as you can see, I have already opened my VS Code editor and created project 2 folder. So before moving on, I would highly recommend you to install Docker extension in the extensions page. As you can see here, click on these extensions and search Docker. And if you have not already installed this extension, please go and click on install. And as soon as you are done, you can just click exit and then we can start moving on. So as you can see, I don't have any folder. Now I'm going to basically here create a new folder, and let's name it project 2. And simply I'm going to drag and drop inside the VS Code. And so now we can start creating our Docker file. So let's create a new file, name it, click on this new file and name it like Docker file. Click on that. And one more thing before moving on, just go to the settings and click on settings. And when you go to the setting, you will see that the autosave on the Visual Studio Code. Click on that and change it to on focus change, because what it does is that an editor with changes is automatically saved when the editor loses focus. So it will basically save everything you write automatically. So you don't have to press Ctrl+C whenever or click on file and say every time you change something. All right, so we can start running entering the Docker file. So first command is from, and the base image would be Ubuntu latest. Well, this command specifies the base image to use for building Docker image. So in this case, we are using this Ubuntu operating system as a base image. And then we need to run the command like apt get update, and then and apt get install -y, not to ask a question, Apache 2, right? So here we are installing the Apache web server onto the Ubuntu base image. The run command executes a shell command inside the Docker container during the build process. And in this case, it updates the package list and installs the Apache 2 package using the apt-get package manager. So the next one is expose. And as you can see, every time I'm writing the Docker file commands, Visual Studio Code is automatically detecting and giving me suggestions because we have just enabled the extension. You can also see this extension on the left bottom here. You can see the Docker. Once we push the Docker file and create a container, I'm going to show that. So let's click on now expose, and we need to enter the port. So in this case, I would enter 80. So the Docker container will listen on port 80, which is default port for Apache web server. However, this command does not actually publish the port on the host machine to the host machine. It simply documents the container will use the port 80, all right? So the next command is cmd, and after that, let's just open the square brackets, and inside that, let's open the quotation mark, and inside the quotation mark, we need to write Apache 2 CTL, comma, quotation mark, -d, comma, quotation mark, and then we need to write foreground, right? So this command specifies the default command to run when the Docker container starts. In this case, we are using the Apache 2 CTL command with the the -d foreground option, which starts the Apache web server in the foreground and allows the container to run as a main process. And also it ensures that container does not exit immediately after starting and that it continues to run until it's manually stopped or terminated. So once we are done with Docker file, we need to go to the terminal and click on new terminal and make sure we are in the right directory. So we are inside the Project2. So here we are going to run the docker build command, docker build -t, and then you have to give the name for the image. Let's say I'm going to give my Apache image and space dot, right? Don't forget to enter the dot, and let's click on enter. And as you can see, it's really fast because we have a really small image. We have really small commands and installations. So once we are done, we need to run the Docker container. So before running the Docker container, I would like to show you this image. Just go to the Docker, click on this Docker extension. And here you can see we have two images. This one I have just pulled before in the first project. And this one is just we have created using a Docker file, right? Now, as you can see, we don't have any containers. So I'm going to create a new container using this image. So for that, we need to run the following command, docker run -p, which means port 8080, and the name of the image, my Apache image, right? The name of the, just make sure you enter the right image, my Apache image, and let's click on enter. And this will start the container. You can see here the container, right? So we need to run as soon as we are done with running the container, we need to verify the Apache web server. So we can verify it by opening a web server and navigate into the local host. And you should see the Apache default page. So let me open my browser, and here I'm going to run localhost. Click on enter, and as you can see, we have Apache 2 default page. So congratulations, in this project you have successfully Dockerized Apache web server. Just as a recommendation, just review what we have done and practice on your own. And I will see you in the next lecture.
Hello and welcome to the Project 3 on Dockerizing an Nginx web server. In this Project 3, we are going to start building our Docker file. So this Docker file installs the latest version of Ubuntu, updates and upgrades its packages, installs the Nginx server, exposes port 8080, and sets the default command to start Nginx server in the foreground. So using this Docker file, we are going to build our Ubuntu image. Then using this Docker Ubuntu image, we will run a container so that will be the part of the project. Next, we'll go a bit deeper and customize this Nginx configuration to serve our own web application by adding our application files to the Docker image and configuring Nginx to serve them. We are going to create simple HTML files which displays simple hello world message. After completing this project, we will become more familiar using building a Docker images, like specifying a base image, installing the software packages inside the image, copying the files to the image, and configuring the image. Using the Ubuntu as a base image, you will also learn how to use Ubuntu, a popular Linux distribution, as a base image from building Docker images. Also, installing web server. You will also learn how to install Nginx, a popular web server software, inside a Docker image, and also you will learn how to use the apt-get command to install Nginx and how to start and stop Nginx service inside the image. You are also going to learn how to customize Nginx configuration Specifically, you are going to learn how to customize Nginx configuration to serve your own web application by adding your application files to the Docker image and configuring Nginx to serve them. Overall, this project will give students a practical understanding of how to use Docker and Nginx to deploy and serve your own web applications, which is a highly valuable skill in the software development industry. And it's great to do this project on your own as an assignment before we proceed together in the next video. Good luck, and I will see you in the next lecture. So let's get started creating Project 3 on Dockerizing an Nginx web server. So first I'm going to create a new folder for this Project 3 by running mkdir project3. Now let's go to this folder, cd project3. And now inside this Project3 folder, I'm going to create a Docker file by running touch Docker file. And if I do ls, you can see we have Docker file. Now I'm going to open Visual Studio Code Editor with this folder. So for that, you need to run code space dot. And this will open us Visual Studio Code Editor with this folder. So you can see that we have a Visual Studio Code, and inside we have a Project3 folder, and inside we have a Docker file. Now we are going to run Dockerfile commands to build our image. So first we are going to run from command and Ubuntu latest. So here we are using the latest version of the Ubuntu image as a base. Next we are going to run command and then apt get update and apt get upgrade -y. So this updates the package index of the Ubuntu image and upgrades any installed packages to their latest version. So now I'm going to run another run command, run and install Nginx. Run apt get install -y Nginx. So this installs the Nginx web server on the Ubuntu image. Next, we are going to run expose command and specify the port 8080. This exposes port 8080 on the container, allowing it to accept incoming requests. So next, we are going to run cmd, and we are going to open square brackets. Inside of square brackets, you need to open quotation mark and specify Nginx, comma, quotation mark, -g, comma, and then you have to open quotation mark again, and you need to include daemon of, and you don't have to, you need to also include semicolon after daemon of. So what we are doing here, this sets the default command that will be executed when the container starts. In this case, it starts the Nginx server in the foreground and keeps the container running in the background. So once we are done with this Docker file, we need to make sure we need to save this Docker file, right? So in order to make sure that you have saved this, you can basically press Ctrl+C, or you can click on this file and make sure you enable this autosave. Make sure you have check mark, or you can go to the settings, click on these settings, and here you can see that we have an autosave. So make sure you are on focus change. So let's exit here, and now we are going to basically open the terminal, click on this new terminal, and now we are going to run the command to build this image. So I'm going to run docker build -t, which means tag, and we need to specify, we need to give the name for this image. Let's say my Nginx image space dot, and if you click enter, this will build image for us. As you can see, it's down. So in order to make sure that our image has created, you can run the Docker images, or you can go to the Docker extension, and inside images you can see our recently created image, my Nginx image, is available. So it's created. Now, using this image, we are going to create a new container. So you can basically come to the WSL terminal, or you can even create your image in this terminal. So I want to go back to the Visual Studio Code at WSL terminal, and if I do Docker images, you can see we have my Nginx image with image ID. Now I want to create a new container using this image. So I want to run Docker run -p port 8080 :80, and we need to specify this name of this image, my Nginx image. I'm going to copy and paste, not to make any spelling error. And if you want, you can come here after port, you can specify, you can give the name for this container. Let's say -- name, and let's give the name, let's say container 1. And if I press enter, this will create a new container. So if I open my Visual Studio Code, and if you go to the containers, you can see there is a available my Nginx image. This is container. So you can click on the right mouse, and you can see there is an option open in browser, or basically you can open your Chrome, your web browser, and here you can search localhost 8080, and you will see the welcome to Nginx image. So it means that's now working. So this is the half of the project. Now in the next part, we are going to customize, and we are going to learn how to serve our own web application inside this Nginx image. So now I'm going to basically go back to the WSL, and now here we need to stop this container because it's now running in the background. So in order to stop, you have to press Ctrl+C, and this will stop. Now we are in the Project3 folder. I'm going to create mkdir, let's say my app. Inside the Project3, we have just created my app folder. Let me go to my app folder, and here I'm going to create index.html file by running touch index.html. And if I do ls, you can see inside a Project3 folder, inside my app folder, I have index.html. So I can go to Visual Studio Code, and if I go to files, my app, index.html, you can see we don't have any code. I'm going to basically run simple HTML code. Here you can see we have simple HTML code, and inside the body, I want to create a h1 tag and h1 header, which is header 1. And I want to say, you can simply write hello world, but I want to write 15 Docker projects for absolute beginners. And I also want to create a paragraph with a lorem, let's say about 30 automatic generated words. And here I also want to create a button, let's say submit. So now you need to make sure you have to save these index.html codes. So as soon as you are done, we are going to go to the Docker file, and we need to make some changes. So after the run commands, we need to come here and say copy. And the copy command asks you to copy which folder. So in that case, my app. And you have to also specify the destination, the name of the destination file or folder. So in that case, we are going to run var/www/html. And once we are done, we need to save this, and we need to come here, or you can go back to the WSL terminal. Let me go one back. Inside a Project3 folder, I'm going to again build the image and run a container. So I'm going to run docker build -t and name of the image, my Nginx image dot. Let's click on enter, and you can see it's now building a new image. Now we need to create a new container using this image. Docker run -p port 8080 column 80 and the name of the image, my Nginx image. And again, I'm not giving any name for the container, but if you want, you can give it. If I click on enter, this will create a new container. So it's now running. If I go to Visual Studio Code and if I open the Docker extension, here you can see we are running one container. So you can also check it here. Or let's now check it in the browser. Let's open browser. And if I refresh this page, you can see 15 Docker projects for absolute beginners. And you can also see the paragraph and you can also see the submit. So this is how you can customize and add your own, serve your own web application for this Docker file for this project. So I would highly recommend you to try this project as your own. Just stop the video and try it as your own. So this will help you a lot. Thanks a lot, and I will see you in the next lecture.
Hello and welcome to the project on Dockerizing a simple Python Flask web application. As you can see that this diagram illustrates the three main steps involved in Dockerizing a Python Flask web application. The first step is to create a Flask application. This step involves creating a simple Flask web application that serves a basic HTML page. The Flask app consists of app.py file that defines the routes and logic for the application, as well as any templates or static files needed by the app. The second step is to create a Docker file. This step involves creating a Docker file that defines the environment and dependencies needed to run the Flask application. The Docker file includes instructions for installing any required libraries and frameworks, copying the Flask app files into the container, and setting the entry point for the container. The third step is to build and run the Docker container. This step involves building the Docker image from the Docker file and then running the container based on the image. So once the container is running, you can access the Flask application in your web browser at localhost like 5000. We are going to take it simple and easy to understand, but as an assignment, give it a try and good luck. I will see you in the next lecture with a Project4 demo. So let's get started working with Project4 demo on Dockerizing a simple Python Flask web application. So as usual, first we are going to create a folder for our Project4. So I'm going to create mkdir Project4 and I'm going to go to this folder Project4. And inside this project, I want to create basically the first app.py by running touch app.py, and if I do ls, you can see we have app.py. And I also want to create a Docker file at the same time, so by running touch docker file, and also if I do ls, you can see we have Docker file and app.py. Also I want to create a requirements.txt touch requirements.txt. Be careful for spelling errors. So if I do ls, you can see we have a necessary files for this project: Docker file, app.py, and requirements.txt. So now I'm going to open it inside my VS Code editor by running code space dot. So once it opens the VS Code editor with our Project4 folder, app.py, Docker file, and requirement.txt, we can start with app.py. All right, so inside app.py, we are going to start some commands. For that, you can go to your browser and simply click on new tab. And if you search on Flask getting started,
you will get some documentation, right? So if you click on that, the first one, the quick start, you can see there is a quick start for this Flask web application. So you can see there is lots of documentation about it regarding the Flask. So the first thing we are going to do here basically we are going to copy this simple Flask codes. You can see that displays the hello world message. I'm going to basically copy this code and return to my VS Code editor. Inside app.py I'm going to paste it, and here we need to add a couple of more things like the conditional statement that ensures the app is only run when the module is executed directly, and also needs to run some host. So for that I'm going to run if name equals to the main, and then we need to say that app.run, and then we need to specify the host 0.0.0.0. Basically this starts the Flask development server and listens for incoming requests on all the network interfaces. All right, so if you're not sure about this the code, I can basically explain it really quickly. So this command basically imports the Flask class from the Flask module, and the second one is creates a new Flask web application instances with the name of module, pass it to the constructor. In this case the name of the module is main, you can see, and the third one is app.route and then slash. You can see this one basically decorator that tells the Flask which URL should trigger the function that follows. And here is our function which displays hello world, basically a function that is executed when the root URL is accessed. So that's it. So simple. So you don't have to worry about it. Just you can access the code and just copy the code and paste it. So once we are done with app.py, we can move on to the Docker file and start creating our Docker file commands. First, we need, as usual, we need to run the base image. In that case, and let me show you from the Docker Hub before we use the Python base image as a base image. So let's go here in Docker Hub, and if you go to the Explorer, you can also search from the search bar. If you go to the below, you can see there is a Python image, so you can see the tags. So basically in this project I'm going to use 3.9 Slim Buster. So from Python and then colon, if you want to specify the specific tag, the version, you can write the column, and that's 3.9, and we need to say it's Slim Buster. You can see there is a suggestion, Slim Buster. And the next command is so basically this will start with the base image that Python 3.9 installed, and the second one is work dir. You can see that it's giving me already suggestion, so you have to specify the work dir path. So in that case we are going to run /app. Basically that sets the working directory to app. And then the next one is copy requirements.txt, and this copies the requirements.txt file to the working directory. All right, so you need to also write the dot after requirements.txt, because otherwise you'll get an error. So basically this copies the requirements.txt file to the working directory. The next command is the run command. We are going to run and install the requirements.txt, run pipe install, and no cache dir dash r minus r and requirements dot txt. Basically, this installs the dependencies listed in requirements.txt. But be careful with the spelling, because otherwise we'll get some error while building this image. And then the next command is a copy, and we need to copy that. So basically this copies the entire contents of the Flask app to the working directory. And then the next command is expose, and we need to specify the port. In that case, I want to specify the 5000, but you can also do the 4000 or 8000, right? Or 3000. So this expose the port 5000, and then the last one is cmd, and we need to open the square brackets, quotation mark, and we need to specify the Python, and here there is a comma, quotation mark, and app.py. Basically this runs the app.py file. So I think we are done with the Docker file. So once we are done with the Docker file, we can move on to the requirements.txt, and we need to basically write Flask. All right, and that's it. So we are done with app.py and Docker file and requirements.txt. Hopefully we will not get any error. So once we are done, we have to go to the terminal and click on new terminal. And basically here we are going to run the docker build command to build this image. Docker build -t tag and the name of the image, let's say my Flask app, and space dot. And hopefully we will not get any errors, but it will take a few seconds. You can see it's now installing. If it takes a lot of time, I usually stop the video and start once it finishes. So don't worry about it. Just wait it and drink a couple of coffee and just have a rest, a few seconds, and we'll get started once it's done. All right, you can see that it's done. So you can basically go to your terminal and check Docker images, and you can see we have my Flask app. You can see the image ID and the size. So you can go to the Visual Studio Code, and if I open my Docker extension, you can also see that inside the images. So now the next step is to create a container from this image. So I'm going to run docker run, and then -p port 5000 and the column 5000, and then my Flask app. All right, and that's all about it. If you want, you can basically give a name for this container, but I have already showed you how you can give the name. That's optional. So I'm going to click on enter, and this will create us the container. And you can see we are getting some small warning, but that's okay. So our container is running. You can see on the top left corner, inside the containers, or my Flask app is running. If I click on this, the container, and click on open in browser, this will open it in my browser. You can see the hello world. So you can customize it, and I have already showed it in my previous videos. So you can come back to the Docker file and customize it. The app.py, you can customize that, the message, and then you can rebuild the image and the container. So that's all about it for this video. So I would recommend you just press Ctrl+C to quit from the container and delete the images and the container, not to take a lot of space from your PC. So that's all about it, and I will see you in the next lecture. Hello and welcome to the Project 5 on Dockerizing a simple Node.js application. As you can see, this project is very similar to the Project 4 that we have done in the previous video, but this time we are going to play around with Node.js application instead of Python Flask application. The diagram illustrates the steps involved in this project. The first step is to create a Node.js application. The Node.js application basically contains the index.js and package.json files that define the application's behavior and dependencies. So we are going to download and install Node.js in our operating system, and then we will start configuring the package.json. The second step is to create a Docker file. The Docker file contains instructions for building a Docker image based on the Node.js runtime, copying the Node.js application into the image, and running the application inside a container. The third step is to build and run the Docker container. The Docker image is a result of building the Docker file and contains all the necessary components to run the Node.js application inside the Docker container. To use the application, we need to open a web browser and navigate to localhost 3000. The browser sends a request to the Node.js application running inside the Docker container, which responds with a hello world message. The Docker container maps the port 3000 inside the container to port 3000 on host machine, allowing the user to access the application running inside the container. So this project is very simple and easy to do because we have already done similar one in our previous video. But it is the best practice to do each project by your own before going through the demo with me in the next lecture. Good luck, and I will see you in the next lecture. So in this video, we are going to work with Project 5 on Dockerizing a simple Node.js application. So as usual, we are going to create a folder for our project by running mkdir project5. And then let's go to this folder, cd project5. And inside this project5 folder, I'm going to create the necessary files that we are going to use during this project. So first I'm going to create a Docker file. And then I'm going to create the index.js. Also, we are going to need package.json. And if I do ls, you can see we have a Docker file, index.js, package, and then package.json. So now I need to open Visual Studio Code Editor with the following folder. So for that, you can run code space dot and press enter. And it will take a few seconds. And now we are inside Visual Studio Code. And you can see we have a Project 5 folder, and inside we have a couple of files, Docker file, index.js, and package.json. So let's start with index.js. So basically we need to add some simple Node.js code to it. So I'm going to copy the code, simple Node.js code, and then paste inside the index.js. So generally speaking, you don't have to understand this index.js code, but just briefly I'm going to explain that. So the first code basically imports the built-in HTTP module, and here it will define the host name and the port number for HTTP server. And here in const server, it will create a new HTTP server that sends a hello world message as a response. And finally, it will start the HTTP server and prints the message indicating that the server is running. So we can basically change the simple hello world message to, let's say, 15 Docker projects for absolute beginners. And we can also specify that we are working on Project 5. We're working with Project 5. And then after that, simply make sure you have to save this index.js. And now let's move on to package.json. And here we are going to basically add necessary information about our application, such as name, version, dependencies, and scripts. For example, I'm going to copy the code and paste it here because it will take a lot of time for writing the code. So that's why I'm just copying and pasting. Don't worry, I'm going to explain every step. So here you can see we are running the name, and here in that case, it's Node app. So make sure to change from Node app to, let's say, Project5. So we are working with Project5 folder. So you need to write your currently working folder, which is Project5. And the version is 1.0.0.0. And you can also provide the description, let's say a simple Node.js application. And here inside the main, we are specifying the index.js file and in dependencies and scripts. So here we're writing the script start and node index.js. So this is all about it for this package.json. So make sure you have the same code as mine. So after that, we can move on to the Docker file and start writing some Docker file. And before that, I would like to show you that you have to install a Node.js if you have not installed it yet on your PC. So let's just go to the Node.js org. And in this side, you can see there is a downloads page on top. Click on that, and there's a two version, LTS and current. So you can basically go to the LTS, and if you are using a Windows, you can install the Windows, and if you are using a Mac OS, you can install the Node.js for your Mac OS. So those of you who are not who have not installed the Node.js, just make sure you install it, and after that run npm install, and then you are ready. So you can move on to the Docker file. So here, as usual, we are going to start with the base image from Node, and then I need to specify the specific tag, the version, Alpine. If you want, you can go to the web browser, open your web browser, and just go to the Docker Hub. And here, if you search Node, and if you click on the Node, you can see there is a Node image from the Docker Hub. Node.js is a JavaScript-based platform for server-side and networking applications. So here you can get the specific tag. All right. So in that case, we are using the Node 14 Alpine. So next command is work dir, and we need to say that /app, which means that it will set the working directory to /app, and make sure you don't have any spelling errors. And then we need to copy, and then /app. So this will copy the current directory contents into the container at /app. And then the next command is run npm install. This will install any needed packages, and then expose 3000. This will make port 3000 available to the world outside this container. And then you can also specify env, which means environment, and then the name. Let's say the Project5. So this will define the environment variable. And the last command is cmd. So open the square brackets, quotation mark, npm, comma, quotation mark, and start. So this will run app.js when the container launches, which means index.js in our case, you can see. All right. So after we are done with Docker file, we can open the terminal and then build our image. So you have already learned how to build the Docker images and then you have already learned how to run containers. But once again, I'm going to show you Docker build -d to tag, and let's give the name as, let's say, node app space dot, and this will build the image for us, and this will take a few seconds. Just wait. So as you can see, after a few seconds, it's done. So if you go to this Docker extension, if you click on the Docker extension on the left, you can see we have a node -app image. So now using this image, we are going to run container by running docker run -p port 3000 column 3000 again. And then we need to specify the image name node app. And we just need to press enter. And this will create a container. You can see inside the Docker extension, it's now loading the new container. So just wait a few seconds and then we are going to open it in our browser. So now as you can see, it's saying the server running at HTTP 0.0.0 column 3000. Just open your browser and then click on the new tab and just search localhost and make sure you specify 3000. All right, let's click on enter. And now, bang, you can see 15 Docker projects for absolute beginner. So I missed S here. And you can see the project 5. So that's all about it for this video. You can see it's not really complicated. It was so easy because we have already done the similar one in our previous video. That's why it was very simple and easy for you. So just make sure you review the codes. Just make sure you review the index.js. Try to understand at least some basic concept to this code, and then just go to the package.json. I'm sure most of you understand these codes because you have some experience in JavaScript. So now the most important thing is a Docker file, how to run the Docker file, how to build this Docker file. So that's all about it for this video, and I will see you in the next lecture.
Hello and welcome to the Project 6 on Dockerizing a WordPress site. Before we start the project demo, I would like to give you some instructions so that you can get some idea about it. So in this project, we are going to start using Docker Compose. So those of you who are not familiar with Docker Compose, it is a tool for defining and running multi-container Docker applications. It uses a YAML file to define the services that make up the application and can create and start all the containers with a single command. So Docker Compose allows you to easily manage relationships between containers, such as dependencies and communications. It also provides features such as volume, network management, environment variable settings, and container health checks. Overall, Docker Compose simplifies the deployment and management of complex Docker applications by providing a declarative configuration file that defines the entire application stack. So let's go through each process in more detail. The first comes is Docker Compose YAML file. This file defines the multi-container application and its configuration, including the services, images, volumes, and environment variables. The next one is Docker Engine. This software runs the containers and manages the resources required by them, such as CPU, memory, and network. Next is MySQL Container. This is a container that runs the MySQL server for the WordPress site. It is created based on the MySQL. We are going to basically use MySQL 5.7 tag, which is a version image, and we use the volume called DB data to store the database files. The next one is WordPress container. This container that This is a container that runs on the WordPress site. It depends on the MySQL container and uses the WordPress latest image. It is accessible on port 8000 on host and runs WordPress site files and configuration. Here it comes the MySQL configuration and data. This includes the configuration settings and data files for the MySQL server such as root password, database name, user, and password. And next it comes the WordPress configuration and files. This includes the WordPress site configuration and files such as theme, plugins, media files. And they are stored in WordPress image used by the container. The next one is DB data volume. This volume is used by the MySQL container to store the database files. It also ensures that the database data persists even if the container is deleted. The last but not the least is port mapping. This maps port 8000 on host to port 80 on the WordPress container, and this also allows the WordPress site to be accessed from the web browser and host machine. So that's it. So now you have some idea about the project, so you can go on and try it on your own before we go through it together in the next video. Good luck, and I will see you in the next lecture. So let's get started project 6 on Dockerizing a WordPress site. As usual, we are going to create a folder for our project. So I'm going to run mkdir. Let's name it as WordPress. Let's go to this folder WordPress. And inside this WordPress folder, I'm going to create a Docker Compose YAML file since we are using Docker Compose in this project. So for that, I need to run touch docker compose.yaml. And if I do ls, you can see we have a dockercompose.yaml. So let's open it inside Visual Studio Code Editor. So here we go. You can see we have a Docker Compose YAML inside Visual Studio Code Editor. So what I'm gonna do here, I'm basically going to copy and paste the whole command, and I want to explain it instead of typing whole the code because it might take a lot of time and I might do some spelling errors if I do fast. So you can see here on top we have a version 3.7. So this specifies the version of the Docker Compose file format being used. So in this case, it's version 3.7. And then you can see we have a services. So this is where you define the service that will make up your application. A service is a container that runs a specific application or process. And then you can see we have a DB services, and then we have a WordPress service, DB service, and WordPress service. So all we have is two services, right? So what is this DB image and MySQL column 5.7? I think you have already guessed it. This is the DB image, which is MySQL 5.7 from the Docker Hub. So this is defined service called DB and sets the Docker image to MySQL 5.7. So this means that this service will run MySQL database using MySQL 5.7 image from Docker Hub. And then you can see we have volumes. So this creates a named volume called a DB data and attaches it to the DB service. And the volume is used to store the MySQL data in the containers /var/lib/MySQL directory. And then you can see we have a restart always. So what it does basically, this sets the restart policy for the DB service to always, which means that Docker will always restart the container if it stops for any reason. So and then you can see we have environment, how you can see your MySQL root password. So you can basically change that. So this basically, these environment variables are passed to the DB container when it starts up. And this sets the root password. You can see database, username, and then password. So the next it comes the WordPress service. So this defines a service, name it like call it WordPress, and sets the Docker image to WordPress latest. You can see we are not specifying a specific the tag, but instead we are specifying the latest. So, and then as you can see here, we are using the depends on argument. So the depends on field indicates that the WordPress service depends on the DB service, which means that the DB container will be started before WordPress container. So, and then you can see we have a ports 8080. So I'm going to change that 8000, or we can also basically change to 8080. So it doesn't matter. So let's do this 8080. So basically this ports 8080 column 80, this maps the containers port 80 to the host port 8080. This means that you can access the WordPress site by going to localhost 8080 in your browser. So the next one is restart always. Like I have already explained it here. This sets the restart policy for in this case, not for the DB, but WordPress service to always, which means the Docker will restart the container if it stops for any reason. And then the same here, we have environment. So then these environment variables are passed to WordPress container when it starts up, and they set the database host, username, password, and database name that WordPress will use to connect to the MySQL database. Last but not the least, we have a volumes. So this creates a named volume called DB data that is used by the DB container to store its data. So finally, what we can do, so like as you remember in our previous videos, we used to use Docker file, right? So in that case, we use it to create first a Docker image and then Docker container. But since we are using Docker Compose, we can basically click on this Docker Compose YAML file, and on the right you can see we have several options: Docker down, Docker restart, compose up, select services. You can say compose restart and compose down. So now we are going to basically click on compose up, and then you will see that it will create these two services. This will create our application. Now, as you can see, we have successfully created this application, and you can see we have already downloaded and created these DB and WordPress images. So the reason why it was really fast in my case is that I have already downloaded these MySQL and WordPress images from the Docker Hub before this video. So that's why. So in your case, it might take a few minutes or seconds. So you have to wait. So once we are done, let me open my web browser, and let's go to localhost 8080, localhost 8080. And if I press enter, you will see we have successfully installed WordPress. Now we need to install the WordPress inside this localhost 8080. So you can basically here choose your language. So I'm going to continue with English United States. Let's continue. And here we need to give the site title. Let's say Dockerizing a WordPress site. And for the username, I'm going to give my name. Let's say Otobag. And here you will see that we have a generated password. I'm going to copy that. So make sure you copy and save it somewhere, or you can also save it in a new tab. So after you like fill it the inputs, you have to also write your email. So in this case, I'm going to write my email. So you don't have to you don't have to write your email. You can also write another email. So let's continue with my email, gmail.com, and I'm going to click on install WordPress. Now, as you can see, we have Otobag and we have a password. So let's click on login. So I'm going to write Otobag for the username, and for the password, as you remember, we have just copied the password for the new tab, and I'm going to paste it here and click on login, but you can also click on this remember me. I'm going to click on login. And now, congratulations, we have successfully installed WordPress, and you can see the welcome to WordPress page. So to make sure our database is working properly, let's go to the posts and let's go to the add new post. And then here, I'm going to write some example here. For example, let's say, hello Docker. This is, for example, this is how you can Dockerize a WordPress site. And if I click on publish, you'll see that, click on publish, and let's click on view post. You can see we have hello Docker post, and this is a subtitle. You can see this is not subtitle, this is the description. This is how you can Dockerize a WordPress site. And here you can also give some comments. Awesome, let's say awesome. Please click on post comment, and you can see we can also comment that. So even if I refresh this page, you can see we have still posts. So you can go to this Dockerizing a WordPress site, you can go to this WordPress and play around with that. So we have our project will be finishing here. So everything we have done this project, you can just review. Let me go to the code again. So make sure you review and understand this Docker Compose YAML file, the version, services, DB, and WordPress, and make sure you understand this depends on. If you are not sure what is it again, just search on the Google and try to understand this whole the Docker Compose YAML file. That's all about it for this video, and I will see you in the next lecture.